My name's Ed Burns, and I'm going to talk to you about the state of JSF 2.2. We're going to go through the first 2 points pretty quickly so we can get to the fun stuff, the actual code and features. First, though, I also want to make a plug for my colleague Roger Catane's talk this afternoon at 3:55 over in the mission room. Techniques for responsive real-time web UIs. So if you haven't booked that in Schedule Builder, that's worth taking a look at. So is JSF really that old? Yes, it is. This is a slide from the Java 1 2001 technical keynote where we introduced JSF, and we're still. The reason it has stuck around is how can JSF still be relevant? Well, abstractions endure, and JSF really is. At the heart, just an abstraction. So we still need to build web apps that are quick to build, maintainable, localizable, accessible, secure, device independent, good looking, and hopefully if you build them right, are fun to use. And the underlying technologies that have been underneath JSF and the technologies that are sitting on the browser side, those have changed somewhat. But you still have the abstraction of components and delivering them and collecting them in pages and views and directing users through flows of these things. So those concepts have stuck around. JSF is still in wide use. It's been used on every continent, including Antarctica. We have an unofficial usage tracker at Real World JSF Links 2. I would update the old one, but bit.ly links are now immutable. They used to not be, but now they're immutable. So that's the one you want to go to if you want to just see what's up and who's using it. This is the slide that people really, I think I want to make sure everyone sees, because this year there's been a lot of talk about really leveraging the capabilities that browsers have come to have now with HTML5. And we can finally say, the browsers are uniformly capable of handling a substantial amount of the user interface logic. In fact, almost all of the user interface logic in the client. So what we're trying to deliver to you with Java EE is the capability to move this slider wherever you like. You can move it and have all the UI state in the client with just RESTful services on the server side, or you could have all the UI state on the server and have all of the stateful stuff happening like with JSF. And the point that JSF is trying to do is we're separating the component semantics from rendering, and we allow the components to own their little patch of the UI. So that's been something that's been in JSF for forever. And this well-defined lifecycle of inversion of control, where the components do their own thing, and you don't need to know what the other components on the page are doing unless you want to. We upgraded JSR 344, which is the spec for JSF 2.2, to JCP 2.8. And there's a number of ways to get involved in track process. I'm going to say this at the beginning so we can get it out of the way. We also have a public Twitter account. If you don't want to, this is quite a commitment. If you want to dive into this level of detail, you can do that. But if you just want to get a notification every so often, hey, there's a new draft available, maybe take a look at it. You can follow JSF_spec on Twitter. And whenever I put a new version of the spec out, I'll send a tweet on that thing. So there's one tweet every month. Not overwhelming at all. We also have a public issue tracker, so you can file your issues and we can look at them. And at the beginning of JSF 2.2, since this is the community access part of the presentation, we had a little voting scheme where we had a poll and we ran it for maybe 2 weeks, and everyone could vote for their top 5 issues. And then we said, okay, these are the issues we're going to focus on for JSF 2.2. And with that, we built the schedule out, and we've been trying to track it as best we can and updating the schedule as we go along. To take a look and review the API yourself, you can go to maven.java.net and just type in the group ID, JavaX Faces API, and the group ID is javax.faces, the artifact ID is JavaX Faces API, the version of course is 2.2 snapshot, and you can look at the Javadoc jar, which will have all, not just the Javadoc, but all of the things of the spec, the RenderKit docs, the JS docs, all of the different parts of JSF are in this jar. We push that out nightly, in fact. Where's JSF in its life cycle? Well, the big release we did was JSR 3.14. That was JSF 2.0, and we are not going to be having any more major blockbuster releases like that, where we're going to sort of introduce a whole new subsystems and really change things around, because we've found that JSF fits well in the kind of place where you have state that resides on the server, and you have components, and you have people that are page developers, and you want to give them sets of components and let them compose their pages with some kind of toolkit widget set type thing. The nice part of that is there's nothing excluding you from having some of those components deliver the HTML5 capabilities, and you can mix and match. You can have both kinds of things happening in your app at the same time. You don't have to go all one and say we're going to have our app be entirely in the client with RESTful services. You can have a part of your app be JSF 2 based, and you can have another part of your app be avatar based that and migrate things over time. So the Java platform has always been about evolving gradually, and the way we're trying to bring HTML5 capabilities to you is to let you migrate to them gradually. So you can continue to use JSF, and as new technologies appear, you can adopt those also. We are hoping to hit public review draft by December of this year, and JCP 2.8 has introduced a number of new requirements that actually put a time limit on things, but we are within the time limit of having to have a renewal ballot. You have to have less than a year between when you have your early draft review and when you have your public review. We published an early draft review in November of 2011. And so our public review, if we have it out in December, early December of, actually I was wrong. I said November. It says right there, early draft review published on 8 December. So if we get it out within a year of that, then we don't need to do the JCP renewal ballot, and everything should just be okay. This blog entry here is Linda DeMichel's blog entry where she announced the change in focus for Java EE 7 to, instead of, has anyone seen this or is aware of the change in focus for Java EE 7? Okay, I'll state it real quick. Prior to this refocus, Java EE 7 was very much talked about as the cloud EE 7, or the cloud EE release. And after the refocus, we've said, well, we don't have enough understanding and cross-vendor support yet for all the different cloud vendors to really say we can solve this problem authoritatively. So we narrowed the focus to deliver HTML5 type technology. So that's why you'll see JSON and JAX-RS and WebSocket being put in there, and JSF 2.2 as well has some HTML5 capabilities that I'll be showing here. And the cloud stuff will now go into EE8. So the JSF story fits into that. We're hoping to have Java EE 7 complete in the spring of 2013. We will be releasing JSF 2.2 along with that EE 7 schedule. And one thing we've always done with with JSF releases is depend only on services provided by one version less in the container. So you'll still be able to run JSF 2.2 on any EE6 container. You'll be able to take the implementation and drop it in, because we're not going to place any hard requirements on any parts of other things of EE7. The only thing that you might miss out on is we have some features that are on the table that leverage JSON and through the JSON API that's part of EE7. So if you take a JSF release and drop it onto an EE6 container, then you won't have that API there unless you pull that back as well. And if you're that advanced at doing stuff, this kind of a la carte mix and match, then either you have a very kind IT department or you're kind of willing to take some more risk on your own hands. All right. Any questions about the schedule and scope and such? I just wanted to ask, when I tell you that JSF 2 was the last big release of JSF and we're not going to rewrite anything and change the focus and say now JSF also does 100% client side, is anyone bothered by that approach? Or, you know? Okay. All right, so I'm a believer in knowing what things are good for and not trying to push things too much all into one bucket. So that's what we're trying to do. Just let things be where they belong and add new things as it makes sense. So I created some bit.ly links for a previous status meeting of this kind earlier in September. So if you click on any of these bit.ly links that I'll be showing you here, they will take you to the issue tracker query that contains those issues, and you can track or take a look at the status, you know, to the commit level of what's been done, how much time has been put in on each issue and such. HTML5 friendly markup support. I call it HTML5 friendly because there's nothing really specifically limited to HTML5 about this. The idea is, why would you want to have a server-side framework in the first place? Well, one reason is because you want to create new tags and you don't want to wait for your browser to evolve. So what are you going to do? You're going to have the ability to sort of do some kind of processing on the server side that makes it so the page author can use these new tags, even the tags that the browser doesn't understand, and then it's processed on the server side, and what gets served down to the browser is different than what was actually in the page. So that's what any server-side templating type technology will do that. With HTML5, now we have a bunch of new elements, right? And so we could either wait for component vendors or kind of make corresponding JSF components that fit that HTML5 model, or we could just say, why don't we build the new system that lets you write regular HTML and just kind of put a little bit of sprinkling of JSF on top of it, and then the HTML that you write will be real, proper HTML, not processed on the server side as far as it comes to rendering, but rather only processed on the server side as far as it comes to processing on the submission of the data. And that's where the JSF request processing lifecycle really has its strength. The validation, conversion, type safety, the EL, model interaction, all of those kinds of things. By definition, HTML doesn't say anything about that, and never has and never will. So that's what the essence of that particular feature is. Did anyone come to my session on Monday with David Schneider about Faces flows? Anyone here there? Okay. So that's good. That means you won't be reinventing or seeing a lot of content. Most of you won't be seeing duplicate content. The Faces flows feature is about collecting modules of related functionality together and enabling you to build your application by composing modules of functionality at a higher level of granularity than just the simple page. So all the pages that deal with browsing and inventory can be collected together into a flow, and all the pages that deal with checking out from that inventory are in another flow. And all the pages that deal with, for example, user account management can be bundled together. And once you have the ability to group these things together, you can reason at a higher level and also do more reuse. So those are probably the biggest of the new features. Cross-site request forgery protection, that was one that was supposed to go into JSF 2.1, but we ran out of time. Loading Facelets via the ResourceHandler, that is getting more and more specific, but that's the ability to load not just the CSS and scripts and images, the so-called assets, through the ResourceHandler, but also the Facelet pages themselves. We are adding one component, the file upload component. I'll explain why it took so long. And multi-templating. That's another of the big features, but I'm not going to talk about too much about it today because we've made not as much progress on the actual implementation of that. Everything I'm going to be showing you demo-wise is already done and implemented in the reference implementation. It's not like totally production quality yet, but it's usable and you can try it and test it out. So let's get back to the basics. JSF views are written in a view declaration language, and the standard Facelet VDL is really an XML application that contains two kinds of elements, either HTML markup or JSF components. And the HTML markup kind of things are just passed straight through to the browser without any processing on the server side. JSF components take some action on the server during the lifecycle. So your page is kind of this collection of template text and JSF components. But when the lifecycle runs, it takes that page and produces this tree of UI components, and the template text is kind of sort of sparkled around all of it, or scattered around all of it. But the browser is what assembles it all together for the user. And on the rendering of these things, each of these components can have an EL expression that points to the model tier, and it can point anywhere you would like in the model tier. And on the render, the EL expressions are evaluated as a get, to get what they show, and on post, the EL expressions are evaluated as left-hand sides, L values, to set what the user typed in. So before JSF 2.2, you had this notion of the tags were hiding the complexity of the underlying HTML script and CSS and images. And so they did this through the concept of a renderer. And the renderer had two things, two jobs. Encode the markup to the browser and decode whatever is sent back from the browser. So with this, you could use, you weren't limited by what the browser had. You could say, these are examples from Prime Faces. Give me a color picker and have its value be that, or give me a calendar. The reason for this is if you're missing a feature in the browser, then you would write a JSF component to fill that gap. The flip side is with JSF 2.2, you can have pure HTML script, CSS images in the JSF page, and the renderer handles the decode as before, but the encode is really just what the page author has written. So that lets you get the best of both worlds. You're leveraging the strength of the JSF lifecycle on the request processing, but you're leveraging the expressiveness of HTML5, and more importantly, probably leveraging the capabilities of your page designer who prefers to work in that way. The page designer would bristle when you tell them, okay, here's a color picker, and you just put it in the page and it will work. And we're like, well, I would like to establish the brand of the color picker and make it fit with the rest of the things I would like. The tags might provide some customizability, but that's not how the HTML designer likes to do things. The same is true with the calendar. Well, because HTML5, I'm using this example, has now added some new input types, you would just using the ones from the browser, and the browser would, open itself up to being styled through the usual conventions that a page designer would like to work with. So the only thing that's JSF specific about this is this JSF :value attribute. And when the facelet processing comes along and says, I see that this element, which otherwise would be considered a simple pass-through element, has one of the attributes from this namespace here. Well, I'm going to treat it as a special kind of thing and take the necessary action on the server side so that it works. So here, if you have a new feature in the browser, but you don't have a JSF component that uses that feature, you would just use this new feature, which is called pass-through elements. So let's take a demo of that. There we are. Okay. Now, these are incredibly unflashy because these demos are actually just taken from the automated test suite that we did as we're developing the reference implementation. The first one I'll show is leveraging the keygen element, which is a new thing in HTML5. So you can choose key to be generated, a public key cryptography type thing, and if we click it, you'll see the browser said, I'm generating a key, and then it sent it on. And okay, this particular demo is just showing the key there. Well, it's not very impressive to look at, but what it does get the point across of what this feature is all about. So let's take a look at the source behind that. Here we are. So here you can see that this is just a regular HTML form that has a couple of these special attributes on it. And here, this is a regular HTML button that has a couple of these things on them. Most important for us, we're saying, even though this is a regular HTML button, I sure would like to have the ability to call the JSF action that I'm usually doing with these kinds of things. Oh, sure. Thank you. What a rookie mistake. You'd think I wasn't doing this for very long. Okay, is that better? Okay. So this is just a plain old HTML button, but it happens to have a couple of these attributes, so we flag it and turn it into an actual command button on the server side. So what it turns out is we've established a mapping between the element name plus some combination of 0 or more attributes to say, when we see this, translate it into one of the h:" tags on the server side. And for those things where there isn't a match, we've defined a number of special purpose renderers that can serve the needs. So for example here, there is no analog in the HTML basic component library for this keygen element, but yet we still want to be able to use it. So if we click on the setter here, this is just a regular JSF managed bean. Well, yeah, it's a JSF managed bean. The reason it's a JSF managed bean rather than a CDI bean, which it should be, is because of this automated test. We would like to have as much of our capabilities as possible running on plain old Tomcat. So we've written this test. There's a whole big section of the test that we have where we choose not to use any CDI features just so we can run them all over the place. But really, I'd recommend you not using these anymore. In fact, the Java X Faces bean package, I'll mention this now. Let me zoom out. Here we are. If you were to download the spec like I showed you and were to look at the Java X Faces bean thing, you'll see now we're going to be deprecating that in a future release. So another nice thing about if you look at the spec directly from java.net, you'll get all these color codings that tell you, which was added, which features were added in this release. So it lets you really quickly look at, say, there's changes in a lot of packages, but there's this whole new flow package. I'll look at that. We'll talk more about that in detail, but I just wanted to show this so you can get familiar with how to evaluate the spec if you want to just see what's new. So going back to Manage Bean, this is my cue to tell you all that you should not be using these because they will be going away. Another feature, this is a smaller one, but it's kind of important because there's a lot of Stack Overflow traffic on it. Has anyone here used Stack Overflow? Okay. They have like 700 pages of JSF questions on there. So we're hoping to address a lot of them. And I really enjoy being able to say, we fixed this one on there now, because people are like, it's a sense of completion. So ViewScoped is one of these things where people would say, I'd like to move my stuff to CDI, but I can't do it all the way because ViewScoped doesn't work, because there's no CDI-based ViewScoped. Well, now we finally added one. So in the flow package, there is a ViewScoped thing. And even though it's an annotation that is defined in the JSF spec, it's entirely dependent on CDI. So don't be dismayed when you say Java X Faces flow at ViewScoped and think, well, is this really CDI? Yes, it is. I'm trying to get across the point that although CDI is defined at the platform level, each of the component EE specs that use CDI can use it in their own way. So because this concept of view scoped is so tightly bound to JSF, we're going to define this particular CDI scope in the JSF spec. So there will be other specs in EE that also use CDI, but define their own scopes that only make sense in the context of using that thing. Okay, so that's kind of a little sidetracked from showing this demo here with the keygen. So this is just a regular JSF managed bean, and we have a new element in HTML5, and I'd like to use it, but I don't have a component that does that. So, what do? You use this pass-through element feature here. So let me just load it again and show the key coming across directly. Button, and submit this guy again. And there's my breakpoint set, and you see this is the public key coming across, being set in a value expression like you normally would expect. So if you already have familiarity with doing things on the server side, and you have page designers that like to do HTML5, then this feature lets you bring those two strengths together. Another example from this demo also is the input. I'm sorry, I know this complex one. So let me look at the page for that one. Complex. And I'll zoom it up for you. Okay. So here we have input type equals text, input type equals tell, input type equals email, and also the progress element. And these things are all new. These different input types are new in HTML5, and the progress element is new also. So what this demo does is shows how you can use these things together. Also, it's very handy you can Ajaxify these things as though they were normal JSF components. So the f::Ajax tag and its corresponding JavaScript function are something we added in JSF 2.0, and they're very easy to use. And Ajax is all about responsiveness and accessing the lifecycle and doing partial updates to the server for the purpose of updating little pieces of the page. And with this feature, you can show combining old-fashioned HTML with the traditional way of doing Ajax in JSF. So here, if we type in a name, Ed, and you see Ajax updated this, and it updated the progress element. And so if we type an email in here, or something that's not an email rather, actually I'll just type this and type out, oops, I pressed the Control-Tab key. That's the wrong one. It gave me a browser validation error that should say, if I mouse over here, tab out again, there it is. Please enter an email address. That's nothing, that's coming straight from the browser. There's no validator you can see on this page. That's a browser feature of HTML5. So, okay. And the progress meter gets updated just by the fact that f::Ajax on the execute phase, we're running the lifecycle on this component here, and we're re-rendering the progress bar. So as we take action on each one, we'll be sending an Ajax request and updating the progress. Okay. So that's that feature. Ah, that's funny. I think I just made a mistake. If I've observed this, there it is. Sometimes if I zoom using the macOS native zoom feature and then go into the VM, things get funny. Okay. Okay. The next one, Faces flows. So large applications have navigation challenges. Basically, before Faces flows, applications are just one large flow where everything is visible and there's no logical partitioning. There's no notion of limited object scoping. There's nothing, in the absence of flows or CDI conversation scope, nothing that spans several pages but is less than the session. Everything is a page. The only way to invoke application logic is to tie it directly to a UI component that the user activates. If you wanted to activate application logic based on a transition or some other kind of thing that's not in the page, you couldn't do that. So we have this Faces Flows concept. And as we all know, standards are for standardizing, not innovating. So we're not inventing anything here. We're simply looking at the prior art of from these places: ADF Task Flows, Spring Webflow, Apache MyFaces Cody are the three big ones that we've looked at to inspire this feature. You can think of a flow like a Java method. You can call the flow from any place in the application that you want to, that you've defined it to be valid to call. They have a single entry point. They have input parameters and return values. They have a well-defined interface contract, which hides the internal implementation details. We've added a new scope, an EL implicit object called Faces Flow Scope. So this scope becomes active whenever you enter this current flow, and it goes away when you leave that flow. We've also added a new flow scoped CDI annotation, which will automatically activate itself when the scope is entered and go away when the scope is exited. And this one is really important because it actually helps you to define the flow graph itself. And this is the flow graph piece of the presentation. Navigation is no longer just between pages, it's between flow nodes. And there are 6 different flow node types: view, method call, switch, flow call, and flow return. And these are the ones that we've kind of found as the union of node types when we looked at ADF, Spring Webflow, and MyFaces Cody. They all had these 6, so we've kind of boiled it down to that. And in talking to the people who work with these technologies, the experts and the expert group, I would ask them, well, are you sure that we need just those 6, And they're like, we've seen so many apps, and we thought about maybe having a custom node type feature, but there really has never been a need for it. So I'll trust the experts when they say, through the thousands of apps that have been built on their technologies, okay, I believe it. So we'll take these and run with it. And if we need to add more later, we can have another version of the spec that does that. But I'm pretty confident that this will serve most people's needs flow-wise. So the runtime representation of the flow is the important thing. How you author it and how it's persisted, in the file system is, in my opinion, less important. So the runtime representation, we have a new class, Java X Faces Flow. These things, once they're placed into service, they are immutable. So this version of the spec does not anticipate creating flows or modifying flows dynamically once they've been placed into service. Makes things a lot easier to understand when you can make that distinction and say flows are immutable. So the flow handler is the class that lets you create flows and add them to the site. It depends on this new feature, client window. Client window is something we really got from MyFaces Cody, and it's something JSF has been lacking forever. And that is the ability to have something that maps to the browser view. So if you have multiple tabs or multiple browser windows, each one of those things will finally now have a client window that's associated with it. And whatever you see in that browser tab or browser window will stick with that client window. And that feature is fundamentally important when doing Faces flows, especially when you have nested flows or when you have a flow that wants to do a subflow that is kind of modal and might block and prevent you from going anywhere else until you complete that subflow. Having a client window is essential for that. The authoring experience for flows is still under discussion. I really would like to not introduce any new XML to the spec. Although the current prototype that we have is using XML, I really think the right thing to do is to have a builder or some kind of fluent API for it, and that's what I'll show here. So those of you that went to the talk on Monday, you'll see that this is very different from just what we did on Monday. because in talking to other folks at Java 1 here, getting inspired by that conference energy that we all come for, it made me kind of want to rewrite things and make them better. So the view node represents the page within the flow. It's what we already know. Any JSF page is one of these things, or can be one of these things. The method call node lets us invoke logic from the flow graph. So it decouples the invocation of logic from the UI component. You have a method identified by an EL expression and an outcome from the method, or you can actually, in the flow definition, define what is the default outcome. So basically, it's a method that tells you where to go next. The switch node is like a Java switch statement. It's similar to a method call, but instead of just being one, you have a list of them, and you go down the list, and the first one that evaluates to true is where you will go next. And of course, you have a default outcome as well there. A flow call node is where if you navigate to this thing, you're saying, okay, I want to leave this flow and go to a different flow, or I want to leave this flow and go out of the flow entirely into the unbounded flow of the application. So this is where you would define the output parameters that you're passing when you go somewhere else, and what return value you're going to send out when you leave. Did I get that wrong? Yeah, the flow call node. This is where you define the parameters you're passing. The flow return node returns to the calling flow, and this is where you identify the return values. Sorry about that. Okay. And the flow definition, this is the key part. It contains the name of the flow, identifies where it starts, identifies what the input parameters are, and the optional initializer and finalizer. So this is what I was thinking would be a better way to define it than just XML. So this does two things here. This is a CDI managed bean declared to be in flow scoped. And when you do that, you have to declare the identifier of the flow that you are a part of. You can have many different beans, flow scoped beans inside the same flow that belong to it. But only one of them will have this produces method on it. That is where the flow gets defined. So here you'll get past a flow builder, and here's where you can define the start node and the return and the switch node, all of these other kinds of things. And this is completely up for grabs as far as how we're going to design this. The other alternative is to have an XML-based syntax, which I will show you when we get to the demo. But I think that a Java-based solution is probably better for this point in time. So here we go to the demo. Okay. All right, let me close this one out. Okay, so here is the simple, and again, this is just an automated test, so it doesn't look fancy. So this one, we enter flow A, and we go a few steps forward, and then we call flow B. And now, when we call from flow A to flow B, we pass some parameters. And let's go through, and this one will call back flow A again and pass some parameters. And now we get the values passed through there. And also, this one will demonstrate the Faces flow scope EL object. And if we go next, you'll see that there. So, all right. How does it look in the authoring experience? That's not the one. Here it is, Faces flow call. So there's a lot of naming conventions involved here. And we have adopted one that if you want to create a flow very simply, just make a directory and give that directory a name, as you have to do. And if you have a file in there, this is the XML definition. This is the way the prototype is implemented. That builder thing is not implemented yet. So if you have a directory that contains a file with the same name as the directory, but -flow.xml, then will get loaded and looked at as the flow definition. So let me plus this up so you can see it better. So this is what it looks like in XML. You define a faces flow return, and you can define your inbound parameters. And here is the flow call node that's saying, okay, when I call flow B, right there, I would like to pass these two parameters. Param1 from flow A, param2 from flow A. And this could be an EL expression here. Okay. If we go and look at flow B, you'll see the flip side of this, where it has input parameters that must match up with what we're passing from flow A. So this is saying, I expect these guys to be handed to me, and you know, what it's going to do with them, it's up to whatever you'd like. But here in this guy, he's saying, I'm going to go and just stuff these in the faces flow scope. All right, let me zoom back out. Now, you can define any number of pages inside here, and they'll all be in that same flow scope. So this is where we say input text value equals faces flow scope this, and on the next page, of course, we are just outputting that value to show that the new implicit EL object is working as expected. And this guy also has a annotated bean, like I showed you there, and this will become active when the flow is entered and inactive when the flow is exited. Okay? That's the flow feature. All right. Okay. Ah, lovely. Look at that. Beach ball. Oh, another thing about flows, you can package them in a jar file. This is what I was talking about with the modularity. So once you have your flows packaged in a jar, then you can really build, test, and redistribute reusable web application fragments. And the first question you might run into with it is, well, if I'm going to make something reusable, I would like to take it from an app that has one sort of visual style to it and use it in another app that has a totally different visual style. But I'd like to use the same flow in both places. And isn't it the case that because the flow has views in it, the visual style will be kind of baked into those views? And well, that would be the case if you could do it that way. But there's another feature that we have called multi-templating, which is kind of the other dimension of customizability here, where with the multi-templating, that's where you put the style and the visual representation of things. And so those can also be interchangeable. So we have the ability to have two different dimensions here. The behavior of the things is encapsulated in the flow jar, and the visual representation, visual style of it will be encapsulated in the multi-template jar. And when we decouple those things, you get the ability to reuse flows without having to bake the visual appearance of the flow into the flow jar itself. But using those two features together gives you that capability. Okay, cross-site request forgery protection. This is one of the things we had on the list for 2.1. It didn't make the time cut, so we are adding it to 2.2. And basically the idea is this attack tricks the browser into sending requests that the user did not actually intend to initiate. So how does JSF protect you from this attack? Well, the good news, it already does and always has. Here's one case where the JSF postback feature is a virtue because everything in JSF has a view state token, and that serves as a built-in level of cross-site request forgery protection. What we added with the feature is we require that the view state is now encrypted by default. You can turn it off, but now we're saying it's on by default. So if someone tries to tamper with the view state and make a request, then their encryption will fail, and you'll get the proper error that says, hey, I'm not going to take action on this thing because you messed with it. That's fine for postback requests, but for non-postback requests, that is when you are going from one part of the site to another from GET, using multiple GET requests. And there's ways to do that in JSF also. Instead of using POST, we have this concept of a protected views element. And there's an algorithm there where when we're trying to access a new view, we will look at these, the view handler will ask, is the view protected? Is it been specifically listed in the set of protected views for the application? If so, let's continue on. If not, well, we'll look at the referrer header. If you're coming from a protected view to another view in the app, then we say that that's fine. So then we'll proceed. If we don't have a referrer header, we'll say, well, does the referrer header at least originate within the same app? And if we do, then we know that we're coming from one of our pages to another one of our pages. So it's okay to proceed. If there's no referrer header, then we'll look for this special non-postback token view param. And that query parameter will be present because we've made some changes to response state manager so that that token is always passed if the feature is activated. So I have a demo of that as well. Right there. Okay, so we're on a non-protected page, and we're doing a non-postback navigation to a protected view, and we're able to see it because we're going from one to the other. We have that token there. But if I was to just strip off the token and make the request again, you'll see a protected view exception. So let's look at how that looks in the page author perspective. Okay. CSRF tests. Here we are. And let's look at the Faces config. So this Faces config is very simple. It has a protected view with a URL pattern that just specifically names this one guy. And that's how we're able to do it. Okay. Okay, the file upload component. So why has it taken so long? Apache Commons file upload has been around for like 8 years, at least. Does anyone know exactly when it came out? 8 sounds about right. Yeah. Well, why has it taken so long? For the benefit of Apache Tomcat users, JSF has always chosen to lag one servlet version behind the EE umbrella spec in which it is included. So because we know that Tomcat is very widely used, and we want JSF to be also widely used. So we've chosen to not really put things in there that would restrict the set of people that can use it. So with J2EE 1.4, even though we had version 2.4 in the servlet spec, we didn't depend on anything except in servlet 2.3, and so on and so forth. So servlet 3.0 was the first version of servlet that had multi-part form file uploads support. And so not until EE7 are we able to do our normal trick of depending on one level behind. So that's why we have it now. It's a very simple usage experience. The final spec will have AJAX and non-AJAX support. There will be some additional JavaScript API that we need to add for the AJAX case. But this is how it looks in the non-AJAX support. You would have a new component, input file, and its value will just be the servlet part that is sent in the multi-part form submit. So we have a manage bean that gets the part. Of course, it has a getter and a setter. And the way you work with a part is you can take this upload file, which is of type parp, and ask it for its input stream, and then my simple example just will scan for some text. I also wanted to show that you can add validators to it. It's a regular JSF input component, so it's subject to the same rules that any input component is. And this guy, because it's a validator, it gets passed a value, and the value is a part. So it just does the same trick. And here in this example, it's scanning for if the string JSR 344 exists in the uploaded file. So let's look at that demo. Okay. Here we are in the browser. And I happen to have two prepared files. This one will fail. This file does not contain, you probably can't see that, but I'll zoom in. This is the text of the file. This file does not contain the required string and will not be set into the model. Okay, let's open that and submit it, and it will give us a validation failure. And this one does, if we look in here, this file contains the string JSR 344 and will be successfully set into the model. So if we select that and submit it, try again. That's funny. Why is it doing that? Success, please. Browse, submit. Yeah, this file contains the string, and so let's just set a breakpoint to see, like we normally have these kinds of things working. File upload, input file. Here we are. If I alt-click on this, here's my file upload bean. So you see the setter is getting called. Oops. I'll click it one more time. I'll upload the failure text to see that the setter doesn't get called because the validation failed. It's not called. But if I update the successful one, we'll see the setter does get called right there. And so this is a part. Another thing to point out, of course, is you have to set enc type as multi-part form data on the form. Otherwise, the browser won't be able to do the right thing. So even though this is an h:" form, you can still pass the enc type attribute. Okay. All right. You don't. Well, with the pass-through element feature, you wouldn't have to. But you'd have to. It would have to be flagged as a pass-through element. Okay. This one is kind of small, but it's important. Loading the facelets via the resource handler. JSF 2.2 added facelets, and it also added resource handler, but these two concepts were not unified. Resource handler was used for helping components to render themselves when they have to do things that go beyond markup. But now with this version of the spec, we are using facelets is depending on resource handler to actually get the file that it will parse and turn into the component tree. The multi-templating feature, that's very similar to Joomla, and basically if facelets lets you template page elements, then multi-templating lets you take that up a level and lets you template site elements. So sidebar, navigation menu, content area. This enables you to define a contract, and you can code your site to that contract, and then any multi-template that implements that contract you are able to use. And multi-templates also can be packaged as jar files. I don't have a demo of this one, unfortunately. The medium-sized features, this bit.ly link will take you to that set of them. We've had a lot of features in the component renderer realm. The window ID thing kind of fits in there. With facelets, we've set HTML5 doc type as the default, so we'll automatically generate whatever you say, unless you specifically say, don't give me this. We'll just say doc type HTML. We've added a Facelet Factory API that wasn't there before. Another fun one, this was also on the list for 2.1, but finally made it in, is View Actions. This is basically like a button that clicks itself when the page is loaded. And you can also customize when the button will have clicked itself in the life cycle. So it's useful for if you want to just do some stuff before the page loads, and you want to make sure that it's always done. We made it so everything is CDI injectable. All of your JSF artifacts were not CDI injectable, all of them before, just managed beans were, but now your components and validators and converters, anything you can declare in JSF is also now suitable for at and inject. Small features, there's a lot of those, a lot of bug fixes in these areas of the specification. So, thank you very much for your time, and we have about 5 minutes left for questions, maybe? I don't know. Okay. Thanks.